Okay, so thank you for coming back today. Today we have two topics. One is accessibility and individual differences, and the other is cultural differences. And I'm experiencing cultural differences here by visiting, but there's ways to talk about that that'll help when you're product designing. So one thing that's interesting about digital accessibility is that, well, I'll get to that in a minute. Okay, first, individual differences. What are individual differences? This is a term from the psychology world that means ways that people differ, right? And you probably have friends who will say, oh, that guy is so good at navigating. He never gets lost, but I get lost all the time. People have differences like that. People have differences. Some are musicians, some are not musicians. So we all have differences. And when you're designing a system or a product, it's useful to understand those differences. So why do people vary, right? It could be different things. It could be genetics, like the music difference is probably genetics. It could be the environment. If you grew up in a really large family with like 12 kids, you might not have gotten as much attention as the only child in a family, and the parents are like, oh, my child, right? So that's going to affect you. We're going to see some sad facts about age and getting older, and then, of course, expertise in your training. So here's what's interesting about aging. They have two kinds of information here. This is age on the x-axis, and these are normalized variables, meaning it's just they've taken a bunch of variables and all put them on this -1 to 1. And when they look at cognitive task performance, like how fast can you do a math problem, how fast can you remember a recipe or navigate, as people get older, they fall down, right? I mean, it's just, I'm somewhere in here in the 50s. I'm like, oh dear, right? So I don't know about my future. But what's interesting with people who are older, like your parents or such, is the world knowledge keeps going up. So they keep having facts, but they're just not as fast at getting to them and using them. So when you're designing a system or a product, depends on the product niche you're in, but it could be that the people using the product are older. And are they older and they have money? Like some older people have more money, they have a career, they've earned their job, they have their money. And so they're going to want the system to be easy to use, even though they have these challenges, right? Here's an example study where people were taught how to square a 2-digit number. So it turns out you can follow some of these rules. I'm not going to go into the rules, but you can pretty quickly learn how to square a 2-digit number and impress your friends if you follow this. And they taught this method to people in their 20s, 40s, and 60s. And so whenever you see a study or you hear about a study, it's useful before you see what happened to think to yourself, what do I predict will happen? So how do you predict the results will be? If people in their 20s and 40s and 60s had to learn this method and apply it, is there a difference? Do you think people? So maybe the first people are faster. And so what do you think would happen if they practice? What if I practice, 5 times? Can I make up the difference and maybe I'm not hurt when I'm old anymore because I practiced? What do people think? Is it the practice effect will make the age go away, or the age will still be there? Okay, in this task right here. This is like, following these rules of math. You think the age will go away? You think the practice will make it go away? Okay, we can be hopeful, right? Because if I'm older especially. All right, so let's see what happened. So we have the older people in the squares, and then we have middle in these diamonds and younger people in triangles. And they had 6 training sessions. And we're looking at working memory errors. So you make a math mistake, or there's calculation errors. The working memory error is like, I was working on the 7, but then I need to remember I'm working on the 7, and you do something else. You come back like, what was I working on? And you forget the 7. The calculation is, like I said, 7 times 2 is 15 instead of 14. So what's interesting is that in the first session, age is a big problem, right? The older people are a lot slower. But as they practice, per Prof. Mohit, right, the difference decreases. So the older people can practice and get almost as good as the younger people. And here, with the calculation errors, they do. So sometimes practice can help, but as you mentioned, it can depend on the task, right?
So it's say that the y-axis.
Sorry, say again?
So in the graph, the y-axis, it's not. Why is it 2, 4, 6, 8, 10? It's the age.
That's just counting errors. It's like how many errors did they make? Yeah. Yeah. Okay, so when you're designing a system, you can think to yourself, will it result in issues like this? How will practice help? Okay, so that's about age. Now, cyber sickness is a thing that I study a lot in my own research, which is about putting on a VR headset or an AR headset, like the AR glasses. And I would say there's 15 to 20% of people who will never get sick. And these people don't get sick on boats or airplanes or cars. They never get sick. And it's probably a genetic thing. And then there's about 5% of people, and you put a VR headset on them, and within 30 seconds, they're saying, take it off, I'm so sick. And most of us are in the middle a little bit. How many people have worn a VR headset? Okay, so some people. And I would say if you're going to wear it for more than about 30 minutes, most people start feeling a little off, maybe just a little like, oh, something's not quite right, or maybe I'm sweating a little bit. Not everybody. And it depends on how well the software is designed. So what affects these are, you have to have good hardware. Most of the headset hardware is pretty good now. There used to be latency in the hardware, but we've gotten rid of that. The task matters a lot. So if I have a task that requires you to look in the distance and then look close, and then look in the distance and look close, you're going to be worse off than if it's just like scan in the front. And then people talk about optic flow. Have you ever seen a science fiction movie and people are in the spaceship and they launch into warp speed and all the stars go, right? That's high optic flow. So pixels are moving on the screen. Yeah. So if you have high optic flow, your brain tends to think that your brain sees that optic flow and it says, oh, you're moving. But your vestibular system in your ear says, you are not moving, you're sitting in a chair. And then there's a conflict. And when there's a conflict, then your body starts to say things like, maybe he ate some poison. Maybe we need to throw that up and get that out of there, right? And so then people start feeling nauseous. So it's this cheap conflict, and there's also a factor of how good you are at balancing. So if you watch me and I'm standing up here and I were 10 years older, I might have trouble not moving. You see this with some older people. You see it with undergrads who don't know how to speak well yet too, but if I have trouble balancing, right, I might be oscillating more. And people who oscillate more as they're standing there, and you see this sometimes with older people, they're going to have more sickness too. What's interesting is that almost all the studies talk about women get sicker than men. And there's a big controversy in this field about, is it genetics or hormones? Or is it the fact that, like if there's a thing called IPD, interpupillary distance, like how far apart your eyes are. The headsets are mostly built for men's eyes, right? And women's heads are a little smaller. Some of the headsets, you can adjust the IPD down, or it'll adjust automatically, and it's like, okay, I'm good for you now. But some of the headsets, particularly 3 or 4 years ago, wouldn't adjust. And so then you're a woman wearing this headset that's not for you. So then it's not that you're a woman that's making you sick, it's that it's not built for you. So there's some debate in the field about why these results are, but almost every study you do, if there's cyber sickness, women are going to get more sick. Motion sickness history is a big influence as well. So if I tend to get sick, then I'm going to get sick in VR, right? Yeah, okay. So one study we did was what we called the cyber sickness corn maze. So do people grow corn in India?
Yes.
Yeah? Okay, so there's some corn. And when you're growing corn in the US, it might get to be 3 meters tall, some of the tall corn, definitely 2 meters tall. And what the farmers will do sometimes for extra money is they'll carve out a maze in the corn, and then they'll invite people to wander through the corn and try not to get lost, and they find things. So we made a corn maze, and we had 3 kinds of tasks for people. One is they are just sort of sitting there and the corn maze is gliding by. It's like they're on a railroad through the corn maze. They're just watching, it's gliding by. And their turns. The other one is called zero back, and it's like every time you see a skunk, there were 3 kinds of animals. Every time you see a skunk, you click on it. Okay? And that's not that hard. It's like, oh, see a skunk, click. The 2 back is hard. The 2 back means only click on an animal that's the same animal that I saw 2 animals ago. Okay? This is the sort of task, if you make your friends do this, they will be mad at you because it's a pain in the neck. So if I see animal A, and I see B, and I see B, and then I see A, I'm like, oh, that's 2 back. That's the same as 2 back. I click it. Okay, then I get C, that's not the same as B. I get B, that's not the same as A, not the same. B is the same as B. I click it. So it's called a working memory task, and it's really hard. It's definitely working your brain. There's also 3 back. You have to remember 3 back, and that's extremely hard. Like a lot of people just can't even do it. So here's an example of the corn maze. You have to ignore the words. When the people saw it in their headset, there were no words. So I think this might be skunk mode, or no, this must be the 2 back mode. And so now every once in a while there's things like you have to climb down a ladder in a pit. And the things we put in the corn maze are known to make people sick. So up, down will make people sick. And let me see. Yeah, that's all we got. We also had a trampoline where as you're going, it's like boing, 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 and that makes you sick. Okay, so our question was, will the working memory make you sicker? So if I give you this 2 back task that's taxing your memory and making you think hard, are you going to get sicker, or is it independent and it doesn't affect your sickness? So what do people think? Are the people in these 3 conditions going to get differently sick, or is it going to be pretty much the same?
I think the 2 back people will get because they are doing so much working memory tasks. The cognitive load on them is so much higher than the control and 0 back.
So you're voting for the 2 back people will get sicker. Okay, who agrees with him? Anyone? Okay, 2 back people get sicker. Sorry?
Sickness is dependent on the task which is given.
It's different than the task?
It is dependent on the task which is given to the...
Well, that's right, yeah. So you think it's going to be more sick on the 2 back? Okay, does anyone disagree? And they think, no, this task doesn't matter. If I get sick, it's really about how the world goes in my eyes. It doesn't matter what the task is.
So there might be a chance that if I apply some type of cognitive load like this one, there might be a chance that it might distract them from the artifacts that are causing motion sickness.
Exactly. That's a great point. And that's one of the things we're interested in. Like when you're looking at the corn maze, what is making you sick? And it could be that I'm just looking for animals. And so like in the attentional focus area, I'm just looking like right here at the animals. So I'm not even seeing all that stuff going by in that corn going on. So maybe I don't get as sick. Yeah, does that make sense? Okay, so this is the big reveal, right? What did we discover? So this is called a hierarchical linear model. And we start out, there's 3 models, model 1, model 2, model 3, and each of them has different parameters. So in the first model, it's the simplest. We just said, okay, if I'm going to model sickness, does the task matter? And we got significance, statistical significance. The task really matters. So the task affects you. And then we said, okay, we got tasks. Now let's add these other things. Let's add gender. And then these are called the big 5 personality scales. So, I don't know, do people talk about Myers-Briggs here? Maybe not. Okay, Myers-Briggs is a personality thing. This is the big 5 personality thing. This is the good one. And so people can be introverted or extroverted. They can be agreeable or not agreeable, right? These are like personality factors. So we said maybe your personality matters. What about motion sickness history? Maybe that matters. Turned out that really does matter. So that's a big predictor, the history. The personality doesn't really matter. Okay? And then we added a last one about how much VR have you done before? That didn't really matter how much VR experience you had. But the workload does matter. So if you are perceiving that 2 back task as high workload, then that matters. And then duration. That's a small number, but it's significant. But it's hard to know whether to pay attention to small numbers even when they're significant. So in models like this, you talk about how much variance in the people did I account for with my model. We accounted for a little over 50%, which is pretty good as models go in human factors world, because humans vary so much. And then here's workload. So we've got the control, the 0 back, the 2 back, and then we've got what people thought was workload. And this is the NASA TLX. Some of you recognize that from yesterday. And so women and men are pretty much the same. Everybody thought 2 back was higher workload. So that's fine. That's fine. This is sort of validating the fact that we intended it to be higher workload, and it was. But here's a little interesting difference in men and women. This is now cyber sickness change, or delta, the delta in the cyber sickness. We survey them at the beginning of the study and at the end of the study, and we say, how much did they change in their sickness ratings? And so before and after, not much difference here. Before and after, some more difference here, but men and women aren't different. And in the 2 back, women had a much bigger difference. So this is the sort of thing where you start wondering why. What is it? Is it the other correlation? I talked about the intrapupillary distance, right, as a problem. The other problem is that we know that video game experience can help decrease sickness because you're spending a lot of time in the video game, so your brain is used to some weird perspectives and visual change. Well, on the stats about video gaming, if you say, do women and men play video games? In the US, at least, there are equal numbers of gamers, of men and women. But then you're like, that doesn't seem right because I see all the men gaming. What's the deal with that? Well, you look into the type of game they're using. So the women are doing more like Candy Crush and mobile games, but the men are doing the first-person shooter games and the 3D games. And so it could be that this men-women difference is about gaming experience. So it's not a genetic thing. It could just be about how much they're gaming. And part of the reason I'm telling you this is so that when you read other studies, I want you to be asking questions about, yeah, but the authors claim this. Is that really true? Right? So I'm hoping to give you the ability to ask these questions and not be so confident and not just believe everything they're writing. Right? Okay. Any thoughts on this before we go on? Yeah.
I have a question, how does one study the variance in the controlled environment when it comes to the sequence of tasks? Because if they do if they do just the control first and then they do the 0 take and then the second.
Yeah.
Does it matter? They have they already have something to refer back to, so that makes their study. Or did you also try making them do the 2 take first and then later?
That's a great question. So this is called within subjects or between subjects. So within subjects is every subject does all 3 tasks. Between subjects is I come in the door and I just do 2 back. You come in the door and you do 0 back. He comes in the door and he just does control. So with cyber sickness, you pretty much have to do that second method. Because if I had you do the task 1 in a row, the first one's going to make you sick and it's going to affect the second one, like you said. Yeah. So that means you need more participants. One of the students I worked with just finished a study with 400 participants, which is huge in human factors land. I mean, it's a lot of people. She took like 5 months, all these people coming.
Making the same person do different tasks on different days or something?
Yes, you could do that on different days. That's right. The recovery differs too. So some people take off the headset and they're like, okay, I'm good now. Other people take off the headset and they feel bad for like 8 hours. And so the companies like Meta and Google worry about this because if I'm feeling off, I may drive my car into a tree or something, right? And then I'm going to sue them. So it really differs. The hardest thing about running studies like that is purely getting people to show up again. So if I say, you're going to come 3 times, typically we say, you're going to come 3 times. I'm going to pay you $10, $10, and $50 on the last time. And then maybe they'll come. But you still lose like a third of the people. Yeah.
Between men and women, sort of different preferences.
Like the preferences of whether they like the corn maze? That's interesting. If they are sitting there hating their life, like I hated that I showed up for this experiment and they're sad, I can imagine that might affect something. I don't have good data on that. As opposed to like, oh, this is cool, it's like a game, if you're pumped up. Huh. Yeah, I don't know, good question. I don't know if it would affect that. Yeah. Okay, so this big picture, we step back now. This is about individual differences. So we've shown that people have different approaches. And so even if you don't care about cyber sickness, you might care about differences that your users have when they're going to use your products. There's a phrase, universal design. Is this a term people have heard? Okay. So I want the product to be good for everybody. And it's actually hard. It sounds nice. You're like, oh, my product is good for everybody. It's equality and justice and all this. But it makes product really hard to design. It's like a pain in the neck. I'd rather say, oh, my product is for males who are below 30, and they're going to be more similar, right? You know, and you're like, no, please. Yeah. So I think as I've been learning more about India here, India is a great place to think about this with all the different cultures in the different regions of India, right? And there are people with different languages and different habits. So if you have a person with a disability, there's basically 3 things you can do. You know, you can get the person assistive tech, right? So if I'm blind, maybe you give me the stick and I'm going to have the stick in front of me. Or if you can change the world so that in the US now, they start, every time you are on a sidewalk, like the roads will have sidewalks, and then when you get to an intersection, there's always a ramp down to the road. And this was originally for wheelchairs, people in wheelchairs. And it turned out it was really valuable for all sorts of other people too, like mothers with strollers and for people pushing their groceries in their grocery cart, you know, down the street. Yeah, and there's this sort of bridge. So here's a brief video. Let's see if we can get this to go, which I think is a nice, powerful thing.
Accessible design is important.
Oh, wait a minute.
Accessible design is important. But is it the same as inclusive design? In this video, we'll tease apart the difference between these two. Web accessibility is defined by the World Wide Web Consortium as websites, tools, and technologies which are designed and developed so that people with disabilities can use them. This means that people with disabilities can equally perceive, understand, navigate, interact with, and contribute to the web without barriers. Now, UX accessibility is absolutely not limited to web design, but UX accessibility means that any user experience, including physical, digital, service design, can be experienced by people of all abilities. It's also not limited just to people with lifelong disabilities. Tech accessibility means a design can be used by people of all abilities. So, acknowledging that everyone has limits to their abilities, and those limits can change at any time. One great example of accessible design is closed captioning. While it might have been created with the deaf or hard of hearing communities in mind, its benefits also extend to people with temporary disabilities, like ear infections, and situational disabilities, like being in a loud or quiet location where audio can't be heard or played. So, accessibility is a goal, a destination. Inclusive design is how we get to that destination. So in comparison to accessible design, inclusive design is a series of design methodologies that focuses on 2 things. 1, understanding, and 2, enabling people of all backgrounds and abilities. This also includes accessibility, but it covers a broad spectrum of differences as well, like age, culture, economic status, education, geographic location, language, among many others. An inclusive design, as a noun, is one that accounts for all of these differences. How do you understand people of all backgrounds and abilities? Well, there's no one way to do it, but I can tell you this: it's not by perspective taking. Perspective taking, or imagining yourself in someone else's shoes, is a mental exercise fraught with bias. Because when you imagine yourself in someone else's shoes, you're still yourself, with all of your own past experiences, expectations, hopes, dreams, envisioning what you might do if placed in different circumstances. And to quote one of our UX mantras, you are not the user. Instead of perspective taking, opt for perspective getting. which is actually talking to and observing people who are currently excluded or who might differ from your typical user base. After all, there might be a very good reason they aren't typical users, like social pressures, familial concerns, or societal and systemic issues. But you can't uncover these reasons with imagination. You uncover them with data. Learn from the people who are the experts of their own lives. Use qualitative research methods to build a deeper understanding of the audience that you'd like to serve. While it might feel overwhelming, the best place to start is by identifying who might be excluded or who might have a hard time accessing or using your services. As for how you might enable people of all backgrounds and abilities, remember that inclusive design is about that, enablement. It's not about creating a single design that is perfect in all ways. It's about creating many ways for people to engage, to equally perceive, understand, navigate, interact with, and contribute. And sometimes meeting very different user needs means having more than one design. At the end of the day, everyone is unique. And while it's not feasible to create an individually tailored design for every single person in the world, any step we can take to make designs usable for a new group of people means gaining new customers. A win for underserved communities, a win for businesses, a win for all.
Thanks for watching. If you want to see more of our UX videos, click.
Okay. So this is interesting, right? And she's saying so strongly, it's not perspective taking, because for about 5 years in the UX industry, everyone was about perspective taking. And you've heard about empathy sometimes. Empathy is a buzzword. And now empathy is getting a little more like, no. You can't really have empathy of somebody if you don't know them or understand them. You need to spend time with them. And this gets to things like you might decide, like when we were building, I talked about yesterday, we were building this software for the traffic managers. And we would go and spend time with the traffic managers and watch them, sometimes 6-8 hours a day. We're watching them and listening to them talk. So you've got to really know your person. Another story on this is I have a colleague who is Chinese, but she lives in the US and she works for Airbnb China. Is there Airbnb here? Yeah, okay. So she was responsible. There's a special part of the mobile interface for Airbnb that if you are a power landlord, like you have 20 properties and you're renting all these different properties, and they've got a whole different user interface for you. And she said, first I designed it for the American users, and then they said, oh, go design it for the Chinese users, but don't spend too much time on that. Just use Google Translate. And she said, yeah, you're shaking your head. And she showed us, she came to my class once on Zoom, and she showed us how terrible this was. Because you just do Google Translate, and like Chinese people think about names really differently. And she would talk about, oh, you Americans with so many letters, it takes you so long to write things. My name is just 2 characters, not a whole bunch of characters. And they think about dates differently. And so when you do Google Translate, it's just changing the fields, leaving them there, but changing the titles, and it was a mess. So then she would talk about Chinese users being confused. So you have to understand the culture, understand the users. Okay. So let's go back to this. So physical disabilities, there's some lingo, and I don't know, this lingo may not apply in India, right? This is the lingo the US uses. I've got some health condition. Maybe I have Parkinson's disease, and so I have a tremor, right? It's hard for me to use phones because my finger's moving. I'm trying to tap. So we've got an impairment. That's like the medical stuff. We've got a disability, and we've got a handicap. And how are these different? So cerebral palsy is another disease of your muscles that makes you can't move. So the impairment is I can't control my muscles. That's just the medical fact. The disability is I have trouble using my mouse or using a phone and tapping. And what that means is the handicap is in my life. That's sort of my life implications, is I'm going to have a hard time getting a job. I'm going to have a hard time even applying for a job. Yeah. So here's some things that typically happen. For example, with keyboards, if you don't control your muscles as well with your fingers, you can end up with, well, I pressed the key too long. And you probably know if you hold a key down, it starts repeating. So then you'll see people like, it's repeating, I didn't want that. or their hand is moving this way, so they press several keys. They wanted to press one key. They're missing keys, bouncing. So this is the higher frequency stuff up top, lower frequency. So what's nice is that somebody has analyzed this for you, right? And then you can take advantage of this. And so in your app, you might decide, there might be people with muscular diseases using my app. I'm going to make my buttons really large. I'm going to make there be more space between my buttons, so it's harder to press the wrong button, right? Here's some mouse issues. Double clicking is really hard if you don't have good muscles, and people sometimes have violent opinions about the double click speed. Like, don't change my double click speed. This is what I like. What you'll see with people who have motor control problems is they want to click on this file and open this file, but their mouse is like moving all around the file. And then dragging is really hard, right? I'm going to drag a file to a new folder, and on Windows, the folder icons are tiny. So, here are some of this is again age. This is the depressing age graph. So we're going from age 45 to 75 plus. Percentage of the population on the y-axis. So as people get into their 60s, a lot of them are going to have arthritis. So their hands are not going to be as flexible. The visual is down here. So we've got visual disabilities. It's not as bad. People often get their eyes, they might have macular degeneration. They might have to have some eye surgeries, but eyes are often okay. Hearing gets worse though too, right? This is US data. Yeah, good point. You might be interested to know, we have red, green, and blue cones in our eyes, and dogs only have 2 cones. I forget which 2 they have. I think it might be red and green. I don't. But the dogs don't see the same colors as we do, right? And there is this amazing creature in the ocean called the mantis shrimp that has 16 cones, and when you look at a mantis shrimp, you're like, oh, it looks like a psychedelic rainbow. So if you're, color is often about mating, and so you can imagine like, oh, I want to remember this shrimp, and I need to have 16 cones to remember that. But blue gets harder as you get older. We start out when we're born, we have fewer blue cones, and then if the cones are sort of dying off a little bit as you get older, then if you lose some blues, you're losing more functionality. Glare gets harder. You might hear, at least I don't know if it happens here. I hear my parents and we'll talk about things like, oh, when I'm driving at night, the headlights from the cars coming towards me are really bright. Like it looks like a big starburst. It used to just look like a white circle, but now it looks like, psh. So people's eyes adjust, and that's harder to see. Auditory here. So do people use smoke alarms here? Where there's like a little gadget on your ceiling and it detects smoke and it goes like a beep. Oh yeah, see there's one right there. So beeps, high frequency beeps are famous for you not knowing where it's coming from. So if we've got 2 alarms in here, and if one of them beeps, we would probably have a hard time figuring out which one it is. We'd be like, okay, so I'm gonna stand here, wait for it to beep, and I'm gonna go over here, wait for it to beep. Because they're high frequencies, it's a lot of waves hitting, and it doesn't work well with our 2 ears and doing location distance. So it gets even harder when you're older. And you'll find if you are speaking to an older population, you want to talk more slowly, right? And it's not that they're dumb. This is what's hard. Because I've seen people speak up to older people and like, so everybody, we're going to go out and do some fun activities now. And it sounds like they're children, right? And you're like, no, don't do that. You just need to talk more slowly. They're still smart. Yeah. The motor skills, I talked about the arthritis, double clicks, okay. So there are things you can do as a designer, like higher contrast, right? I don't want to see like blocks that are gray with black text on them. If it's the gray block, I want to see white text, right? That's going to have contrast. The amount of visual search, so I have to look all over the screen, Some of you have seen the ways different software has delete buttons. So if there's a powerful high consequence feature, it might have the delete button in big red ink, that sort of thing. It'll have a confirmation. Do you really want to delete like that? So you need to do some things like that. So children, what about the children? You know, what do you do for them? Turns out they have lower motor dexterity too. Sometimes you need more repetition. You have to worry about child safety if you're taking their data and there's a chance some stalker is going to be online. And there's a lot of controversy in the US about if it's okay to have kids have screens at all. Right? I think the current US pediatrician, like the Doctors Association, says no screens before they're 2 years old. And then we recommend no screens until they're like 10 years old. And a lot of parents are like, well, that's dumb. You know, but people are doing studies to see how it's affecting folks. Because the companies are all out there trying to get your eyes more on the phone, right? Okay, how are we doing? You have a question, yeah?
So this thing about this talking about no screen for 2 years at least, or even 10 years.
Yeah.
Now, in India, some people believe that if a child is exposed to a mobile phone early in life, he would pick up those things so fast that he would become much better later when he grows up in handling such. Is that correct?
So I wouldn't believe that necessarily because the phones are so easy to use. I don't think we need to train them early. Like if you give a 10-year-old a phone who's never seen a phone, they're like, I'll learn it. And in 5 minutes, they're good. So I don't think it's like a skill like soccer or something like, or football, right? Or cricket that you wouldn't want to learn from early on.
Look at us, we started using phones much later than we have been fine now.
Yeah.
And Australia, in fact, banned using screens for children.
Sorry, say again?
I think Australia banned personal phones for children already. Till a
Yeah.
certain age.
Yeah, right. And there's the worry that most people have is about attention span. So, you know, the phone responds to you immediately, pretty much, or maybe not immediately, a little bit of delay if there's some network lag, but it's going to respond to you. And you are always in control. So in real life, how often are you in control? Like, not that often, right? And how often do things happen immediately? It's like, not that often. Sometimes, you know, if I trip and fall on the ground, I get an immediate pain, right? So there's some of that. But life is not really immediate and with you in control. So really you need to, you know, have more training and walking around and having your skin knee, you fall and you have a skin knee and you pick up and you say, I'm fine. You know, I feel like there's more training to do that. That's just my opinion though. But I think a lot of the studies are worried about attentional span going down.
I guess like for a long time, phone, as long as the phone was being used as a tool, things were going fine. But now that the content is being designed to decrease our attention span, and now with the AI, and there was a recent MIT study which said that it's really messing up with our brains.
Yeah, it's going to be hard. I feel like the phone use and the AI use too is a little bit like saying, I've got a free buffet for you with all the food you'd ever want. And you can just have as much food as you want. And by the way, you should try to eat only the healthy food. But, you know, all the food is there. And you're like, oh, I don't have time for healthy food today. I'm going to grab this fried thing, you know, something like that. So with the AI, it's like that. It's all the features are there. And in an MIT study and others will say, you should only use it for these purposes. But you're like, oh, but it's so easy to use for the other purposes. So it takes a lot more self-control. And humans don't have a good history of self-control, you know. Yeah.
Babies, till they grow for like around 6 to 7 months, they are not able to see all the colors. That's what medical side they say. You had mentioned about that optical flow. How is it usually measured?
The optical flow. So if you're measuring optical flow, usually you get like 2 frames of a video. Maybe here's frame 1 and frame 2, and you map the pixels on and then subtract the difference. So if between frame 1 and frame 2, you know, 10% of the pixels moved, and you're like, it's got an optic flow of about 10%, as opposed to all the pixels moved, and it's like, oh, it's like 95%. Something. It's like things like that, like little vectors.
In today's reading that you had given about empathy, there was something about slipperiness of empathy.
Yeah, it's slipperiness of empathy, yeah.
I didn't get it. It's this is all heavy stuff that you've given us because we would probably have to read it again and again.
Yeah.
So this thing that you mentioned about inclusive design, where they're talking about perspective rating, but now where do we draw the line and say that too much? I don't know if it's about too much empathy and it's affecting the whole design.
Yeah, so for a while, everybody was talking about empathy. You have to understand your customer and their needs. What are your customers? Oh, my customer is a middle-aged mom who is really stressed because she has 4 kids and she's running around, something like that. So you understand the mom, but you are not a middle-aged mom, like most of you, right? So that's the empathy has been getting the pushback. So people were like, oh, I'm going to imagine being a middle-aged mom. And it's like, well, you can't really do that very well. You can't, I mean, you're just not going to imagine all the things. And so it's much better to find 10 middle-aged moms and interview them and follow them around like a shadow for a couple hours. And then you're like, now I understand middle-aged moms. So that's the perspective giving part. Like you're actually getting the data from them. And so I'm trying to remember to link this back. You asked about something. Oh yeah, so that was the empathy. So the article I put in the folder was about empathy getting sort of pushback. So for a while it was empathy, and now it's like, nah, not so much. Yeah. So is that helpful?
If I may ask,
Yeah.
you mentioned that bottom up and top down influence on perception. How do we understand that?
Top down, bottom up. So this is interesting. You have a retina in the back of your eye, right? The retina's there. It's got all the little like receptors. And the wires from that retina go to the back of your brain, like back here, is all the part of your brain processing vision. And there's I think it's about 50,000 neurons going back. So there's a lot of wires. But there's even more wires going to your eye. Okay, and you're like, what? Because why do I need to go to my eye? My eye is a sensor. It's like a camera. It's like, well, no, it's not. It's being tuned. And so if you are panicked that there's a tiger over here, and you are really looking for tigers, then all the features of your eye that are tuned to stripes and like movement in the shadows are going to be highlighted. And so and from those wires going to your eye, it signals about like, pay attention to this, filter this way. So our sensors are actually really tuned by our goals, which is a little startling. I mean, we don't fully understand it yet. We just know that there's these tuning systems. So we're not just like a camera, right? Does that help? So the top down, I guess that's to answer. That's the top down. The top down was like, I need to watch out for tigers. And then the bottom up is like, oh, I see this pixel, I see this pixel, I see this pixel, and I see, green and orange, and what do I make of all those? So the bottom up is like, oh, I see some orange, and it looks like they're in continuous movement, so that maybe that's a stripe, and you're sort of working your way up. As opposed to at the top, you're like, I want to look for tiger. And then you're going to break that down. Yeah. Okay, this is a video I wanted to play of somebody who's blind, who's using a phone. Has anyone known or seen somebody blind using a phone? Okay, so I think it's fascinating. We had a blind graduate student getting his master's in HCI. And in this video, she's got the phone turned on to show us what she's doing. But if you're blind, you don't need the screen, right? So the screen is off, and you have really great battery life. And the other thing that they'll do, you'll hear it talk really fast. And do they have in India here these TV commercials for drugs? And then at the end of the commercial, it's like, and you may die, or you may have all these side effects. So in the US, it's like, this could enable you to have no more arthritis. And it's like, but some specification they apply, and you may die, and you may have constipation, and you may, and it goes through. So our brains can hear faster than normal people can talk. Okay, so the blind people have realized that, and they'll often have the voice at 3x. Like you and I will get lost at 3x unless you practice, but they're practiced, right? So let's watch this.
Hi, I'm Christy. I'm just showing a little video of how a blind person would use an iPhone. So basically, you go to...
Can you hear this?
You run your finger along the screen and you find what you're looking for. And there's like a little bit of a vibration, so it helps too. And it reads everything on the screen as you're going. And so then I open Twitter.
It's talking to her as she's doing this.
Top of the Twitter page now. And I'm gonna compose a tweet. And normally you would use the regular keyboard here, but the iPhone also has this other keyboard where when you turn it, it's now I can braille and use a braille keyboard. So
So this is like typing Braille.
And so then I can read what I wrote. So I could share that if I want. But that's pretty much the idea. And so
Okay, I'll stop now for here. But it's interesting to think about all the technology that Apple and Google and Android created for people like this. Right? There's all these hidden features in your phone that most of us don't play with. And in one class I had, we spent about 30 minutes turning on the voiceover and exploring it. And generally students responded like, I don't know how to do this. This is really confusing, you know, because you have to practice it. In the US, there's accessibility laws. There's this government accessibility law that says everybody has to be able to do everything, no matter what their ability, which means you have, if there's ever a building with stairs, there's a ramp for a wheelchair. So it costs more, you know, because you have to build extra stuff. But it does mean that the Android and the Apple OS system have a lot of these features built in, which is nice. I don't know if, you know, a Huawei phone does the same thing or not. But, so I'm going to move ahead. For JAWS is, it's going to talk you through a web page. So it's software that's free and you can install on your computer. And then when you bring up a web page like NewYorkTimes.com or somebody will be like, NewYorkTimes.com. And then you're like, first headline, and it tells you the headline. So here's some other situations besides blindness.
Okay, sir. Thank you, sir. Thank you, ma'am.
Okay. To get past this.
Web accessibility perspectives. Video captions. Video isn't just about pictures. It's also about sound. Without the audio, you'd have to guess what this film is about. Frustrating, isn't it? Not knowing what's going on. That's the situation for everyone who can't hear. Captions make videos accessible, which is also handy for people who want to watch video in loud environments, or where you need to be very, very quiet.
Can you hear that the guy has a British accent? Is that obvious to you? Or not so much?
Colors with good contrast. There's something about great design that allows it to go practically unnoticed. But it doesn't take much to make things confusing and frustrating. Choosing colors with poor contrast makes navigating, reading, and interacting a real pain. Good design means sufficient contrast between foreground and background colors. That's not just text and images, but links, icons, and buttons. If it's important enough to be seen, then it needs to be clear. And this is essential for people with low contrast sensitivity, which becomes more common as we age. With good colors, websites and applications can be easier to use in more situations, like in different lighting conditions. Voice recognition. Imagine if you could only communicate with your family by writing. Sometimes it's just easier to speak. One of the advances of technology is voice recognition, whether it's searching the web,
19th century architecture,
dictating emails,
Send email to Jack Hard,
or controlling your navigation app. Many people with physical disabilities rely on voice recognition to use the computer.
place order,
But for that to happen, websites and apps need to be properly coded.
go, cancel,
Voice recognition can help lots of other people with temporary limitations too, like an injured arm.
Place order.
It can also prevent injuries becoming worse, like RSI, repetitive stress injury, or for people simply preferring voice.
Text to speech.
Some people can see the text on the screen. Fortunately, computers can convert text to speech.
It's technology that many people who are blind have been relying on for years. But it's also important for many people with dyslexia. and very useful for people with difficulty reading text, as well as some people who just like to multitask. But for this to work, websites and apps have to be properly coded, which has the added benefit of helping search engines index websites' contents better. Clear layout and design. Poor layout can be very frustrating. And the same applies to the web. Good design involves good layout, and that means a better user experience. This includes clear headings, navigation bars, and consistent styling. Any web user will get frustrated with bad layout and design. Complex layouts also make finding information difficult or impossible for people with visual disabilities. And they are confusing for people with cognitive and learning disabilities who need clarity and consistency of the presentation. Bad design also impacts anyone who isn't particularly confident around computers. Notifications and feedback. All the right gears can be put in motion. The hands can be at the exact place they need to be. But if you don't get the response that you're expecting, you'll end up wondering if there's some sort of problem. It's the same on the web. Without clear notifications and feedback, people are quickly disoriented and confused, especially error messages, which are often complex and confusing. Yet making them understandable is usually quite simple. Making websites and apps predictable and understandable makes them accessible to people with cognitive and learning disabilities, and more usable for everyone, especially for people with lower computer skills. Large links, buttons, and controls. Trying to hit a small target requires lots of effort. Many websites and applications try to thread the needle. But on the web, we can make areas for clicking and tapping larger and easier to use, which is handy on mobile devices, especially when we might be moving around at the time, which is critical for people with reduced dexterity.
Customizable text. What's right for you doesn't necessarily work for the next person. Customization isn't always just a question of preference, though. Sometimes it's a necessity. Being able to adjust the text is crucial for people with low vision and dyslexia. Properly coded websites and applications allow the text to be customized. For example, to change its size, spacing, font, and colors without loss of functions or clarity. Understandable content. Instead of saying, to postulate a conceit more irksome than being addressed in sesquipedaling syntax is adamantine, it is better to say, being spoken to in unnecessarily long and complicated language is a pain. Yet many websites lack structuring, using headings, lists, and separation. Or they use overly complex language, jargon, and unexplained acronyms. It makes them difficult and unappealing to use for many people, including non-native speakers, and makes them unusable for people with cognitive and learning disabilities.
Keyboard compatibility. Not being able to use your computer because your mouse doesn't work is frustrating. Many people use only the keyboard to navigate websites, either through preference or circumstance. Whether it's temporarily limited mobility, a permanent physical disability, or simply a broken mouse, the result is the same. Websites and apps need to be operable by keyboard. Web accessibility, essential for some, useful for all. Visit w3.org/WAI.
Okay. So there's a lot of information, but I hope your impression is like, wow, there's more than I realized to think about. There's also these websites, the W3C website. It's a US website, but it goes through all the things you can do, in great detail. And then there's website checkers. So you can say, hey, I built a website. How am I doing on accessibility? And you run it through their checker, and it'll say, like, oh, you need to add word text on the images for people who can't see and describing the images. You need to add this. You need to add that. So, yeah. So I think we're getting close to the end here. I just thought, this is a guy from Texas that I knew. He came to Iowa State. He had a friend who had one arm, and he wanted his friend with one arm to be able to play the shooter video games that his son really liked. So this kid would come over and play with his son, but the kid couldn't play the video games. So he made this glider thing, and so you put your feet on it, and it's like pedals, but then there's also these little switches, so I can put my foot here and then lean in the foot. So if I lean in the foot, it's another mode, because it'll go like click. And so you can like navigate, like go forward, backwards, pivot, turn, shoot. So this kid now with one arm can do everything that the buddy can do because of this foot pedal thing. And he was trying to sell it on Kickstarter, that sort of thing. WCAG, that's the web stuff we talked about. There's mobile, and there's what